Hello, I'm Roman. Welcome back to the series of videos Neural Networks from Scratch in Golang, where we're using a book called Neural Networks from Scratch in Python. We're writing everything with the Golang. And in the previous video, I finished the chapter 19 that is called a real dataset. I actually didn't check what we have here, so the sample code for the. Okay, so this is the pure everything that is done for now. This is 4 years ago. Okay, with the Python in one thing to do the model training. I'm curious. 19. Next one will be in chapter 22, and that will be the last one. Okay, so in the previous episode, I finished it. So right now we actually, for example, we have a fashion. Let's call it the fashion dataset. We downloaded it in a couple of videos before. Basically, it's a collection of the images of the clothes, and we created the neural network that predicts. Well, actually, we created a training process that will train in on top of the dataset to be able to predict type of the cloth. And there are actually, I think if we will take a look, there is assets 10 classes that we can predict. Yeah, and before going, the next chapter is actually model evaluation. I kind of think it shouldn't be a big one. Yes, so maybe I will cover it today. But before we going into this, I actually want to change a couple of things in the training. In the train method, there are a couple of repeating steps that I have to do. For example, the creation of the batch based on the number of the steps and calculation of the batch size. I consider I want to move it out in the helper functions. So that will be, the train method will be cleaner. So let's do this. The first thing is to calculate the train step, right? Based on the training data. So the training data is model data. What I will do, I will create a func, calculate steps, and it will take model as model data, right? But actually, no, I need to take the data set itself, not the training data. Oh no, the training data. Okay, so what do we do? I will copy this and I will go in the end. So we take in its model. Oh, and we need the batch size. Batch size int, right? Yeah, we don't need this. We don't need this. And then we rename steps equals to count, then again steps and steps, and this one again steps, and then we return it. Too many return int, right? So then what we do here, so that should be train steps equals to calculate steps for training data, right? And the same we have for validation steps equals to calculate on validation data, right? Okay, I don't need this. Sorry, yes, batch size. What's happening? Batch size and same here. Okay, So the next thing is to make a slice of the data based on the batch size and X and Y. What is X and Y? I think X and Y is the training data. By the way, what if I will move it? Okay. How would call it? Make slice, no, make batch from the model, right? It's actually model okay, so it's not the model, it will be data. Model data. I think that will be a better name here. Same here, right? Model data and reference to the batch size int, because based on this we will understand what do we do, and actually we'll return dance and dance again, right? So let's do this. I think that should be the copy. Okay, so we have batch size X. Okay, then we take it from the data X and data Y. Okay, data X teams steps. Why do we need steps? Okay, batch steps int, right? Steps batch size. Oh no, it's actually step. And then we have the data X. Okay, here we have data Y and data Y, same here, right? Then we return batch X, batch Y, right? Where is it? So basically here, so batch X and batch Y will make batch, and we take in the train data, we take in the step, and we take in the batch size, right? And that's it, right? What you don't like, X is declared but not used. Real? Okay. And then the next thing is okay, again, batch X and batch Y equals to make batch, validation data, step, and the batch size, and that should be eliminated, right? Okay, you don't need this. I mean, this should work. Why do I need the Y then? Where it's used? That's it. So okay, training data Y. Okay. Does it make sense? Let's try make run. Make run. Okay. Seems working. Seems training. Okay. I would consider it as done. I think this is much better. So it's refactor model train to reduce code duplication, right? Yeah, I mean, it's working. Epoch 4, but we can meanwhile continue with we can continue further with the model evaluation. Let's see how much time spent. 11 minutes, not that much. Okay, in the chapter 11, testing out of the sample data, we covered the difference between the validation and the testing data. With our model up to this point, we have validated during training, but currently we have no great way to run a test on the data or perform a prediction. To begin, we're going to add a new evaluate method to the model class. This method takes in samples, so the validation, target outputs, and an optional batch size. First, we calculate the number of the steps given the length of the data and the batch size argument. This is the same as in the training method. Okay. Then we're going to move a chunk of the code from model class train methods. Which one? Okay. This is funny because I just did this, the calculation of the steps and the slicing of the data. The only thing that I need to... No, I will need to pass the model, or is it model data here, but that's fine. Okay, and this is the part that we will copy paste, really. And we give validation loss, validation accuracy, print result. We'll move that code along with the code part for the number of the steps evaluation, resetting accumulated loss and accuracy to the evaluate method, making it. This is the for the steps. So this is the whole evaluate method. Okay. Now, where that block of code once was in the model class train method, we can call the new evaluate method. If the validation data is not nil, evaluate. Okay. If you're confused about the reference to the validation part of the tester, that's called the start expression, unpacks validation data list into singular values. Now that we have this separate evaluate method, we can evaluate the model whenever we please, either during training or on demand by passing the validation or testing data. First, we'll create and train the model as usual. Okay, train with the validation. We can then add the code to evaluate. Right now, we don't have any specific testing data besides what we have used for the validation data, but we can use this for now to test the methods. Okay. The validation. The validation. Okay. The validation accuracy and loss are repeated twice and show the same values at the end, since we are validating during the training and validated right after the same data. You'll often train a model, tweak its hyperparameters, train it all over again, and so using training and validation data passed into the train method. Then, whenever you find the model and hyperparameters that appear to perform you the best, you'll use the model to... Okay. Next, we can also run in validation and testing data. Validation here means that we evaluate the model, but we have done this using the training data. We compare that to the result of the training on this data, which we have just performed. Interesting that it's different. You might notice that despite using the same dataset, there is some difference between the accuracy and the loss values. The difference comes from the fact that the model prints accuracy and loss accumulated during the epochs, While the model was still learning, those mean accuracy and loss differ from the evaluation on the training data that had been run. Okay. Running evaluation on the training data at the end of the training. Running evaluation on the training data at the end of the training process will return the final. Okay. In the next chapter, we'll add the ability to save and load our models. We'll also construct a way to retrieve and set the model's parameters. Okay, so basically the next thing is to create the evaluate method so we can reuse it in train and in the, this is the train, this is the evaluate. Okay, so let's do this. Okay, so what do we have? This is the model train. Okay, let's do func model evaluate. What it will take? Data, model data. What else? Do I need the number of the epochs? No. Xval, yval. Oh, and we need only the batch size as the reference to the integer. That's it, right? So the next thing, we do the validation steps. Where is this? Okay, we have the validation step, then we calculate if batch is not nil, calculate steps, right? Which means evaluate if batch size is not equal to nil, validation steps, and we have the data. Yes. Okay, then we call in model loss function reset, and then we do the same for the accuracy, right? Reset accumulated. Okay, then we doing this. Train step for the step. The only difference is it will be validation steps, right? Step is declared but not used. Okay, then we go into do the slice. Where is this one? Batch y and this. Okay, again, that will be data. Then what do we do? Okay, basically right now I'm copying this, I think, right? But I guess I can just print this. Let me check. Validation steps, the only difference is data without this. Batch X validation output. Yes, then loss calculate, lost validation predictions and the accuracy, then take validation. Okay. Print the summary, and then what we do, I just change inside this, and I do evaluate validation data and the batch size, right? What do you don't like? Okay, I don't need this anymore, and I don't need this. What else? Do I have other problems? Okay, which means it should work again. Well, actually, the train will work as expected because I didn't change it. The only question is if I messed up with the validation, so we just wait. And we called it a Now that we have this separate evaluate method, we can evaluate the model whenever we can. This is our model declaration. We can model evaluate, right? So for example, here run fashion model. We'll go and I can do this model evaluate, and that will be okay. Validation data, and that will be this one, validation data, and then again validation data and batch size. That should be like this. Now we can also run, and I can do, I don't have the training data, wait. Training data, this one, right? Train data. Which means that if I go here, I can change and evaluate. And then print evaluation. Training. Okay, let's run it once again. I will have the results from run fashion. I'll have the evaluate on the validation data and on the training data. So we just need to wait for a while. And okay, I will just check the results, and that will be the end for today. How many chapters actually left? Saving, retrieving parameters, setting parameters, saving. This one is interesting, but I think, well, I will follow the same logic, but the code will be very, very different. This is the interesting part, the actually running the inference server. I think there are a lot of the code here, and probably I will try to run some web service or something else to actually do this. So there are just a lot of the codes, and then there is a caution, which is very, very small. Okay. So let's take a look. Oh no, this is a real data set. Wait, it's not this table of the contents. This one. Actually, like this. Okay, let's take a look what we have. So I have the training. That is the first evaluation right after the training. So this is called inside the train method. This is called outside of the train method. And I see the same, that's correct. And this is the evaluation on the, this is the on the validation data, and this is on the training data. And yeah, this is a little bit different. So this is the full accuracy and the full loss, but this one is averaged from what we have here. So this is, this is the true value. Okay, so the only thing I want to change is number of the spaces. I don't need the space here. Just makes me, also there is a, okay. let's do this one style. Yeah, that's it. We have the accuracy, learning rate, loss. Okay, I think what I will do, I will house but loss and the accuracy. The loss. Okay, the loss value, accuracy. Okay. Let's commit this. So what do we have here? No. Oh. Unstate changes. Okay, so for the model, yeah, we just moved into the evaluation, and here I just moved the training data and validation data into separate variables, so I can reuse them later. Okay. And evaluate bank. Okay. I think that's it for today. That was a very short video, but you know, it's Saturday for me, so I can record it a little bit shorter, but basically I think this one will be a very big chapter, so I can start next, and yeah, we will write serializer and deserializer for the model, which is, I mean, basically it has nothing to do with the neural network itself. I would say it's this more or less a standard software engineering, like writing some code to work with the files. And yeah, maybe I'll do small changes to improve the model description so we can, you know, see the number of the nodes, etc. Because I think we'll need to write this type of the information anyway, so we can retrieve it, but that will be in the next video. But for now, thank you for watching, and I see you tomorrow. Bye bye.